So our learning targets for today, we're looking at lesson 4.1. So remember, we started a new chapter today. As a side note, our test corrections were due Sunday night, so last night, and not a ton of people turned test corrections in. But
I couldn't.
I know, we'll talk. If you want to do it, then we can still work that out. But, it is Tuesday today, so 2 nights ago. But we can talk about that, Taylor. And we can get that figured out. But anyway, today we are moving on to chapter 4, and it's called translations. So we'll go over that in a second. Our learning targets for today: students will be able to perform translations and compositions. Those sound kind of complicated, but all that means is that we will be able to take an image like a triangle on our graph, and we'll be able to move it somewhere else on our graph. Students will be able to solve real-life problems involving compositions. So a translation is taking our triangle and moving it once on our graph. A composition is taking our triangle and moving it, not once, but twice. So moving our triangle twice is a composition. So our order of operations today, you could also call it our agenda, but order of operations is kind of mathy, so I'm going to start calling it that. First, we are going to review, which we kind of already did, but we're going to review again. And then we're going to look at overview of presentations. That's not what it should say. But we're going to look at a few terms, and then we're going to look at a couple theorems, and then we're going to practice. So pretty good stuff on the agenda for today. So first, tell whether the red figure is a translation, reflection, rotation, or dilation. Now, I'm 99.9% sure, at some point in middle school, we have talked about these terms. Maybe or maybe not. They sound kind of familiar. So as a review, let's just quickly go over them. And these are what we're going to talk about over the next couple of days. So if we have a decent handle on these terms, then we're doing pretty good. Let's start with a reflection. Which one of these would we say is a reflection? Anastasia? The first one, right? If there was a line right here, then this lightning bolt is reflected over that line. So reflection. Very good. Now, so that's off the table. Which one would we say is a rotation? Second one? I agree. Because we just took this image and we just kind of rotated it around. Now, how about a dilate? Oh, I'm going right in order. But how about a dilation? Yes, Anastasia. The third one. I honestly did not mean to do that. That's terrible spelling. It's right there. Third one would be a dilation. Because the size changes, right? That's what happens in a dilation. When we think about dilating, someone gets their eyes dilated. Have you ever seen anyone with their eyes dilated? Really? Like actually? What happens to their pupils when someone gets their eyes dilated? They what? They expand, yeah. You look at someone that just got their eyes dilated, they look like a character from Star Wars because their pupils are huge. I'm not sure why Star Wars, but that kind of works. So that's dilation. And then that leaves us with a translation, which we'll be talking about today. And you can see in this fourth one that all that happens from the blue to the red, does it change in size? Does the direction change or rotation? No, it just is changing its place. That's all that happens in translation. We're changing where something is placed. Nice job. So, with that said, it's as easy. What we're looking at today is as easy as talking about something changing its place, but there are a couple more. It's math, so there's a couple more complicated terms that have to go with something easy. So these are the terms that we'll be talking about today. Well, over the chapter. So what I would do if we're taking notes on this is I would draw this picture. And then after you draw this picture, I will label each one of these on this picture. So you don't need to write down each of these definitions, but I would, like I said, draw this picture, and we'll label each of these on the picture, and that'll be enough of a definition. So take a second in your notes to just draw that picture. And you don't even need to put the grid lines in the back. You can just draw the green arrow and then draw the two black arrows and then just write the 5 units, 3 units, and label DQ. You don't even need the grid. So, we're going to label these, and if you want to just label them with me, and if you want to write a little note about each term, you can, but I think just labeling them will give you a good idea. So, first, a vector. I'm going to change my color. A vector. So this green line, with this green arrow, is our vector. And all that a vector does, like it says, the technical definition is a quantity. So we could find how long that green line is. A quantity that has both direction and magnitude. So just the vector tells us our line. Well, I'm getting too far into this. So the vector is just that line. And like you see here in the middle, it is labeled with the starting point P and the ending point Q. And notice on top, I'll make it a little bigger. But on top of it, it's like an arrow, but only has one prong. It's not like this, because if it was a full arrow on the end, that would be the label for a, does anyone remember? Array. I know that's a long time. So that green line is a vector. Now the initial point is the starting point of the vector. So right here, point P would be the initial point. Point Q we call the terminal point or the ending point. So if we had a dot on a graph and we were moving it, then we would say, the beginning of that dot is our initial point, the end of it is our terminal point, and it is moved on the vector. How are we with those first 3 terms? Nothing crazy. Now the horizontal component. Horizontal, horizon, right? The sun comes over the horizon, so horizontal would be like our left to right. The horizontal component is just this 5 units. That's talking about how far horizontally does our vector move. In this case, from the initial point to the end point, it moves 5 units to the right. So that could be negative, right? If it moved, 3 units to the left, then we would say it moved a negative 3 units. But to the right is positive, just like on our graph, and then up and down, up is positive, down is negative. So in this case, the horizontal component is 5. The vertical component is, big surprise here, 3. Would be our horizontal component, or our vertical component. How far we move up or down. from the initial point to the terminal point. And then component form is just talking about how do we write that change from the initial point to the end point. So it's written like this. We kind of put, it's not quite like a less than sign, but it's a little bit more opened up, but it's also not a parentheses. It's got a point at the end. And we write first our horizontal change. So horizontal change, and then we write our vertical change. And this would be considered right here, component form. Our horizontal change first, and then our vertical change second. And we know that we're talking about component form because instead of parentheses, we put like these. It probably is a legit name for this, but not brackets. That would be tuppence. We good? Nothing too crazy on that first slide. Like I said, it's math, so we have to put some interesting terms with it, but they're really not insane ideas. Is everyone good? Can we move to the next slide? Okay. Now, if we think about big picture for a minute. Well, before we do that, just look at this slide. Just look at it. Everett Sawyer, look at this slide. Just look at it. Does everyone see it? Now that slide to get transformation across the umbrella took a solid 20 minutes. So everyone look, Sawyer, do you appreciate that slide?
Did you make it?
I did. Yep, I had to do a separate text box for each letter, and then I had to like grab the letter and rotate it around, and then I got done, and it ended, like the N was over here, and the T was right here, and it was way off, so then I had to move every single letter. It took a long time. So that's why I want you all to see it. How nice it looks. Anyway,
Very nice.
chapter 4 is called Transformations.
Love the school.
Yeah, nice. See, also, thank you, Layla. I started a new template, right?
Yeah,
we had the
it's
green.
different.
We had the green ones.
Yeah,
Now we
with all
have
the
an orange and
space
black
and
one.
stuff.
Yep, super cool. So, that was good. Our whole chapter is called Transformations, and we're looking at different types of. No, I didn't put Transformers. But we're looking at different types of transformations. All that a transformation is a movement, in this case on a graph. So when we looked, where did it go? At our review. There it is. These were all, these were all transformations. A translation, which we're looking at today. A dilation, which I think is Wednesday, reflection tomorrow, rotation maybe next week, something like that. But all these things are under the umbrella of a transformation. So you'll see.
Yeah, you can set it so I can make it at any time.
That's what I did.
Yeah.
Yeah.
That would, I hate doing that. I can't wait to take this stupid quiz.
I don't even have to go to school. I can just stay home, but I've got to wake up by 9.
I woke up at like 12 every day, okay? It's not
All right.
consistent.
So the whole thing is transformations, and we're looking at one type today, a translation. Moving on the graph.
You spent like 3 minutes talking about your slide.
That's because it was sweet. Now, this is more what we'll see with problems and things like that. You can see in gray this initial triangle right here, A, B, C, is on a graph. So what a question might do is it might say, hey, point A, B, and C are here, here, and here. Now we have a translation, and we want you to plot where these new points end up. And those new points we call A prime, B prime, and C prime. Now those orange lines, what would those be considered? What would those be called? How are we what? Based on the terms. Based on the terms we just looked at, what are those?
Ray.
No, they're not array. They look like array. But that's what we would have called it in the first chapter. Starts with a V. There are vectors, right? because it takes point A and it moves it to A prime. So we consider each of those orange lines one of our vectors. Now, is there anything that we notice about all those vectors? What are all of them? Do they intersect? They have a little triangle on them, so they are all parallel. Yep, all of our vectors are parallel because they're all moving the same direction and they're all changing the same way. Also notice that translation does not change the size or the angle or the angles in our triangle, right? Our triangle started as ABC, and when it went to A prime, B prime, C prime, it was the same size, just in a different location. So all translation does is change location. Now, if we look at an example, the vertices of triangle ABC, so I'm going to have to graph this. This is a classic question that we see. ABC, our A is 0, 1, 2, 3. Here, 2, 4, and 1, 0. So A, B, and C. So there's our triangle. Translate, so move ABC using the vector 5, negative 1. So based on what we know so far, what does that 5 mean? Where are we moving things? That 5. Horizontally, and it would be to the right. Yep, very good. If it's a positive 5, we're moving 5 units to the right. So, if we are writing our new points, A prime, so you would take A and we're moving it 5 units to the right, that means instead of 0, it would be 5. And then what about that negative 1? What are we doing there? Moving how many units up or down? We're moving 1 down. So instead of being at 3, we're going to go down to 2. So there's A prime. Now with B prime, we do the same thing. We're at 2, adding 5, so that would put us to 7. And 1 plus 4 would give us 3. And C prime would be 6, negative 1. So now we can plot these points. A prime is at 5, 1, 2, 3, 4, 5, 2. There's A prime, B prime is at 7, 3, and C prime is at 6, negative 1. C prime. So see, we can move our triangle, and if we wanted to draw our vector in, we could. Right, our vector would go like this, moving each one of those points to its new spot. So that's all a translation is. They give us a point or an image, and we are moving it. Now, one thing to point out, we call this original one in blue, and this is something that you'll either want to write down or make sure that you really remember good. Our original starting, like triangle ABC, we call that our pre-image. And in red, this is just our image. So you'll see that language. They'll say your pre-image is triangle ABC. Find the image using the vector whatever. All it's saying is find the new triangle, or find the updated triangle. That would be our image. Now, we look at component form, right, where they put our change in those kind of an ordered pair, but not quite an ordered pair. They also will put our change in the change that's happening like this. saying x plus 3 and y minus 1. Which means, guess what we're doing to the x's? We are adding 3 to each of the x's. Guess what we're doing to the y's? We are subtracting 1. So it says graph the quadrilateral ABC with vertices, and it gives those points in its, in its image after the translation for x and y. And you'll see a lot of times these translations, they'll write them like this. For an ordered pair x and y, here's what we're changing. We're doing x plus 3 and y minus 1 for each one. They also will say, sometimes write a rule. And if we're writing a rule for something that happens, it would be in this form right here. X plus or minus something, y plus or minus something. Would you guys like me to go through and graph the original and show the change, or do we have a decent handle on this stuff? Yeah, you got it? Or yeah, you want me to graph it?
I got it.
Got it? It's okay if we don't, but it's just graphing, and then for every x add 3, every y minus 1, and give our image. Now I think this is the last thing before you're going to do a couple problems on your own and get your worksheet. You have a lot of time to get that done. So, first, before we look at our postulates, and our theorem, the term. You do not have to write this term down. It's easy to remember it, but you might want to jot it down. A rigid motion is a transformation. So remember, our umbrella, everything that we're looking at, these changes are all transformations. So a rigid motion is a transformation that preserves length and angle measure. So right now we're looking at a translation, and like we talked about, the translation does not change the length of a side, or does not change the measure of our angles at the side of the triangle. So it's considered a rigid motion. Like it says, kind of extending on that, it maps lines to lines, rays to rays, and a segment to a segment. So all it does is, you'll hear the term map, is that it says, all right, it starts here, and it's going to end up here. It's not going to change its form or anything like that. It's just going to change its location. So postulate 4.1 says that a translation, what we're looking at today, is a rigid motion. No surprise there, we've talked about that over and over. Theorem 4.1 says that the composition of 2 or more rigid motions is also a rigid motion. So what that means is they might say, they might give you an original triangle, and then they might say, okay, change it based on this vector, or these components. So then you would write your new one, wherever that might be, and then they would say, all right, with your new one, change it one more time. So you would change it twice. And they call that, again, a component. When we're doing multiple translations, we call that a component, or composition. And all that Theorem 4.1 says is that if we were doing a composition, so if we were doing 2 different translations, then our beginning one is still the same image as our end. It still has the same lengths, still has the same angles, all that kind of stuff. Any questions? What we talked about, the idea really isn't that complicated, right? We're talking about graphing some things and just changing where it's at, changing a new graph. But the terms are some things that we're not used to. So, putting those terms down, getting used to the language that they use here, might be the most difficult one. There are your 2 problems that you need to do and show me before you earn the worksheet. So go ahead, work on those, do those, and then I'll give you the worksheet. And that will be it for today.